Okay, let's take a look at this problem. This is a new concept when it comes to synthetic division. It says 2 and -5 are zeros of the function. Now, I'm going to interject here just for a second to reiterate something. If 2 is a 0, right, that means x minus 2 is a factor, right? We've gone the other way with some of these, right? So when we did this problem, for example, we were checking to see if this was a factor. So we used the 0 of -3 and we found out that it wasn't, right? And then we did this problem, right? And we used, this is the linear factor that we talked about many times now. And we used -6 as the 0 to do the division, okay? So this, I want to emphasize the connection between what a 0 is and what a linear factor is. So if we have the 0, we put it in here. If -5 is a 0, then the linear factor would be x minus -5, which is x plus 5, right? Okay. So again, just an aside there, that doesn't have any bearing on this problem at this point, okay? But I wanted to emphasize that connection there. It says use these two zeros to write the function as a product of its linear factors. What does that mean? Product meaning multiplication of its linear factors. Now this is x to the fourth. If we're going to write linear factors, these are linear factors, right? If I'm going to multiply all these together and end up with x to the fourth, that means I'm missing two factors, right? Okay, so this one, we're going to take this one in parts. Now, one thing that we've learned about synthetic division is if you know something is a factor, then when you do synthetic division with the 0, you should get a remainder down here of 0, right? So let's do this synthetic division with 2 because it's written first. So I have 4, and then I have 12 for my x cubed term. I have -49 for my x squared term, -27 for the x term, and 90 for the floating constant. Okay, this 4 comes down. 2 times 4 is 8, and we add 12 plus 8 is 20. 2 times 20 is 40, and we add, we get -9. 2 times -9 is -18, and we add, we get -45. 2 times -45 is that's my 9, -90, and we get 0. So again, this 0 right here confirms that 2 is in fact a 0 and that x minus 2 is a factor. Okay, so we can say right here, here's our confirmation. Therefore, x minus 2 is a factor because we got a 0 remainder. Okay, now what do we do now, right? We know that -5 is a 0. All right, do we have to start this process all over again? No, we don't, and this is key. So you want to write this down. I'm not going to write this down, but you may want to. You can do synthetic division back to back. I call it piggybacking. So when we do this division by 2 and we end up with this quotient, now we can divide this quotient by -5, by this 0. Okay, so I call it piggybacking. We jump right in and we do it again with another 0. It's totally fine. It's kind of like, as an example, like let's take 12 when you're doing prime factorization, like 2 times 6, right? 6 is really 2 times 3. It's like we're doing that division 2 times in a row if you know something is divisible. So we know this is divisible by -5, so we can do this one more time. Now we drop the 4 down again, right? The process doesn't change here. So we get -20, we add, we get 0. -5 times 0 is 0. -9 plus 0 is -9. -5 times -9 is +45. And sure enough, we get 0 for this remainder. So again, this is telling us that x plus 5 is my second factor. Now, what is a factor? what is the result of this division, right? The quotient, what are we looking at? We've talked about this in a previous video, okay? When this was 4x to the fourth, okay, every time we move this number down, the exponent for x decreases by 1. So in this place, this 4 is 4x cubed. And when we move it down to here, this 4 is 4x squared, okay? We have no x term, and then we have minus 9. So we divided this monstrosity of a polynomial function from the beginning. We divided it by the 2 that was a 0. We got this. Then we divided it by the -5 for a 0, and we got this. So where we stand right now, we know that x minus 2 and x plus 5 are factors. And the remaining factor that we have here is 4x squared minus 9. So this is the product of factors that produced that big 4x to the fourth, blah, 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 right? But the problem started by saying we want the function as a product of its linear factors, right? This factor is not linear, right? It's quadratic, and it's a very specific quadratic, right? It's one of these binomials that we're supposed to be on high alert for. This is the difference of squares. So with the difference of squares, I can always factor the difference of squares into conjugates. I take the square root of this, which is 2x, and it goes in the front of each of these quantities. I take the square root of this, which is 3. It goes into each one of those quantities. One gets a plus, one gets a minus. And this is our function. This is our product of linear factors now. Every value of x has an exponent of 1. That makes them linear. And we have 4 of them, which makes sense because I would have to multiply all those x's together to get x to the fourth. Okay?